Hi, and welcome to Meetings in Math. You are here for section 8.4, Areas of Composite Figures. Our essential question is, how do I find the area of composite shapes? Today you will need your Jaguar Jots on section 8.3, a pen or a pencil. You may find multiple highlighters helpful today. A calculator, your self-confidence, bright ideas, and always bring your problem-solving skills. One of the essential concepts for today is to remember that when you have a composite shape, it's made of multiple pieces. And today we'll need to break it into those smaller pieces, such as rectangles, triangles, or parts of circles. And then to find the area of each piece and add them together. In order to do that, we need to remember that we have formulas of some of our basic shapes. For example, a triangle is area equals 1/2 base times height. And for a rectangle, the area is equal to base times height. The little subs right there, see how the words kind of drop below the area? That's called a sub, so area sub triangle. That's one way we can keep track of having multiple A's and then what that A is corresponding to. One of the ones that we do not have listed in your Jaguar Jots is the area of a circle, because this is the circle chapter, which means we've been working with it a whole lot. But just in case you don't have it, remember the area of a circle is equal to pi r squared, and you might want to jot it down so that you have it right now in this section. So let's begin by finding the area of this composite shape. So the very first thing we need to do is we need to look at our diagram and then make a plan and then decide how we want to break up the figure and then just write it out. And so remember, we write these things out so that we don't have to keep it all up in our brain. We want to use our brain for problem solving, not for like going, what was I going to do? So we write it out. The other reason we write it out is so we can communicate with one another what it is that we're doing. So the way that I was looking at it was, I decided to draw a straight line down and break it into this pink and this blue. And so I'm going to find the area is going to be the pink rectangle plus the area of the blue rectangle. And then after I've done that, I'm going to go find the areas of those parts and then I'll bring them back to the original plan. So the idea is we have this big idea and then we're going to do some smaller sub problems to get the whole picture done. So when I look at the pink rectangle, I can see that it is this one right here, this 9 by 8. So the area of the pink rectangle is base times height. So 8 times 9 or 72. So this here is 72 yards squared. And now I need to find that one. But I'm going to go ahead and substitute that in right now so that I can see where I need to go next. So where I need to go next is I need to go find the area of the blue rectangle. And when I look at it, it's actually a square, but that's okay because all squares are rectangles. So I'm still okay calling it a rectangle. Again, it's base times height. So do you see here, I'm still writing down my formulas. So this is 6 times 6, which is 36. So this blue one right here is 36 yards squared. So this is my total area. I can see I have found it, but let's come back over now to the math where I'm going to show it. So I replaced the blue rectangle with 36, and now I add it together, and I get 108 yards squared. And so I can see that when I have these two, I've found the complete area of the figure, and then mathematically, this is how I'm showing it. So this is how I'm showing it pictorially, and this is how I'm showing it mathematically. We want to work towards showing everything mathematically with equations so that we can see the relationship between the numbers. We want to make sure that our units are in yards squared because area is square unit. This is the exact same picture, but is there more than one way to break up a shape? And you know what? Sometimes there is. So this is the way I broke it up, but look at this. What if instead I did the horizontal line? And you can see it still makes the shape, it just looks a little bit different. I'm going to work through that one really quickly. So instead of this 8 by 9 and 6 by 6 that we used, now we have an 8 by 3 and a 14 by 6. Where did I come up with all those numbers? Well, the 8 by 3, so here's 8, and the 3 came from the fact that I know this is 9 long, and I know this is 6 long, which means this is 3 left over to get to the 9 total. 6 plus 3 is 9. So that's going back to finding missing pieces. And then the 14, we don't see a 14 up here anywhere, but if I know this is 8 long, and I drag that down here, and I know this is 6 long, and I drag it down here, 8 plus 6 is 14. So this would be 14 long. So this one would be 6 by 14, and this one here would be 8 by 3. So our pink rectangle would be 6 by 14, which would be 84. And our blue rectangle would be 8 by 3, which would be 24. And so when we came over here and we put it together, I still get 108 yards squared. I just got to it in a different way. So be aware that if you are working with somebody on a problem, you may see the problem differently, and there's nothing wrong with that. You do need to go all the way down to the end to see if you're coming up with the same answer. So now let's look at this composite shape. The first thing you need to do again is look at your diagram and make a plan and decide how you want to break it up, and then write that out. So how do you want to break this up? There are sometimes some more obvious ways than not. For example, this one to me is a pretty obvious triangle and square, or at least a triangle and a rectangle. So if I was to take this line, that 7, and bump it all the way out, there's my triangle, and then there's my square. Because that line came from this over here, and then I bumped it all the way to there, that's why it's 7 long. So we know that the base of that triangle has to be 7. So then what happens? Well, then I need to find the height of that. Okay, this is where it gets kind of funny. So now I know that from top to bottom, this is 11. And I know I use 7 of it right here. So how much is left right here? If this is 11 and I use 7, how much is left? That is a subtraction problem. So that means that 4 would be left. 11 minus 7 is 4. So this length right here would be 4. So now that we have all of our missing pieces, we can go ahead and do the problem. Let's go find our parts and then bring them back. Let's work on the triangle first. So the area equals 1/2 base times height. Let's look for the base and the height. So the base and the height have to be at 90 degrees to one another, and we found those. So the base was 7 and the height was the 4. 1/2 is 7 times 4. I'm going to actually take half of 4 to begin with. So half of 4 is 2, so 7 times 2 is 14. So that means that this triangle right here, this triangle is 14. So I'm going to go and I'm going to substitute it in there where it's instead of triangle, I'm going to write 14. So now I had to go find the area of the square. So the square is base times height. And so that's this right here, base times height. So the base was 7 and the height was 7. So 7 times 7 is 49. And so now what I'm going to do is I'm going to take that, and I know it's the square, and I'm going to substitute it in for the square. And now I have 14 plus 49, which is 63 meters squared. Why is it meters squared? Because all areas in square units, and our units were meters. So now it's meters squared. So these problems look a little complicated just because there's so much going on. But remember, what we're doing is we're doing big idea and then little idea and little idea. So breaking it into the chunks that we know how to do. So now let's find the area of the composite figure here. Now this one is a lot more complex because there's a lot more going on. But the nice thing about this one is they drew in all the inside lines. And so we can very clearly see we have a triangle, we have a rectangle, and we have a semicircle. What we cannot clearly see is what all of those sides lengths are. For example, I can see that this rectangle is a 4 by something. I can see that this triangle is a 4 by something. And I can see that this semicircle has a radius of 3. So let's begin by writing down our idea. I know I'm going to add the triangle, the rectangle, and the semicircle. And instead of getting caught up in, I can't do this problem, let's just do what we can. And then you're going to find that you can do a lot more of it than what you maybe necessarily thought. So let's just take the pieces as we go. Let's look at the triangle to begin with. So when I look at the triangle, I remember that if my sides are parallel and they're the same length, I can just pull them over. So I can pull that side over and look, it's 4. So I do know the base and the height of this triangle. I also know that if this is 3 and it's the radius, then this side over here also has to be 3 because it's also the radius. And the same idea then, if this is parallel to this, I can just move it down and it also has to be parallel. And 3 plus 3 is 6. So I actually was able to find some of those missing sides. Now let's go find the triangle. So we know triangles are equal to 1/2 base times height. So if I'm looking at this triangle right here, my base and my height are both 4, and we'll substitute that in. Half of 4 is 2, so 4 times 2 is 8. So I know my triangle has an area of 8. So now I can take my triangle and I can replace the word triangle with 8. And I just keep on going. I need to know the rectangle and I need to know the semicircle. I think I can find the rectangle pretty quickly, so now I'm going to move on to the rectangle. I know rectangles are base times height, so I know that the base is 6, and I know the height is 4, so 6 and 4, and then I'll substitute them in, and 6 times 4 is 24. So now that I know that's 24, I know this is 24, and look, I replaced rectangle with 24. So I'm just moving along in the problem. So now I need to find the circle. So I start by recognizing that's a semicircle, which means the area is going to be 1/2 pi r squared. So I need to know the pi and the radius, of which I know both of them. I know pi is 3.14 and I know the radius is only 3. So I'm going to substitute them in, and I'm going to go ahead and do my exponent first. So 3 squared is 9. And then I can do this multiplication in any order I want. So I did 1/2 of 3.14, which is 1.57, and then 1.57 times 9 is 14.13, which means this area is 14.13. So now I can just add all of those up and I get my total area. Most of you are probably really close to doing this. It's just going to take you longer, A, because you still have to calculate all of this, and I had it all calculated out before we started it. And B, you have to recall a lot of the information that I know automatically. You do have to give yourself confidence, though, that you can do it bit by bit. Start off with your big plan and then slowly chip away at it. So now let's look at this last one. What would be your plan for finding the area of this composite figure? I see that I could break it into 2 rectangles, the 11 by 4 and the 5 by 5. So something like this. Let's look at another one. What would be your plan for this one? I see a triangle, this triangle right here, that has a base of 8 and a height of 7. And I see a semicircle that has a diameter of 8, or we could call it a radius of 4. And then we would just chip away at doing those pieces until we got to the answer. That was a lot of information. Thank you so much for joining us. What I would like you to do to finish up this lesson is I would like you to write down the first step in finding the area of a composite figure. There is so much information in today's lesson. Thank you so much for sticking with us. And I promise you, as you do more of these, they will get easier. You just have to remember to chip away at them. Write that big idea down and then chip away at those little pieces, because I promise you, you do know how to find the area of triangles and rectangles and circles. I can't wait until I see you in the next lesson. And remember, be kind to one another, because we can all use some extra kindness in our lives. Bye for now.